All right, it's 9:30. Welcome to Logs Are Magic. Why Git workflows and commit structures should matter to you. I'm John. I go by Gene Hack most places online, and I would like to thank you for coming out to the hangover slot. The struggle is real, y'all. In my day job, I am the Vice President for Technology for Infinity Interactive. We're a custom software development technology consulting company, and I'm required to tell you that if you have any problems, I would love to help you solve them, and you should come find me and talk to me. I wanted to give this talk because I love revision control. I have kept my home directory under revision control for over a decade, the whole directory. I maintain a Perl Git wrapper module because I was stupid and accepted a commit bit from Chris. And I wrote this thing called GitGot to automate batch operations across multiple Git repositories. That's a whole different talk. So I liked CVS. This was one of the first revision control systems I used. I liked SVN a little bit more. Hell, I liked RCS. That's a lie. Nobody ever liked RCS. Is anybody still using RCS? 3, 4 people. Wow. Awesome. So, and now we have Git. Yeah, now we have Git. I love Git. Git makes me happy. So, how many people have used Git at least once? That's pretty much the whole room. How many people feel comfortable with Git? Pretty much the whole room. That's good. How many people would call themselves Git experts? Few people. All right, you people aren't allowed to talk anymore. What this talk isn't, so if you're not at least a little bit familiar with Git, but everybody is, this talk isn't that interesting. Most of the stuff I'm going to talk about applies to all revision control systems, but all of my examples and specific recommendations are very Git-centric. I'm also not claiming to dispense any universal truths in this talk. Pretty much everything I advocate for, you will be able to easily come up with an example or a hypothetical situation where I will say, yeah, don't do that. I'm not even going to try to convince you that these are best practices. All right, so what is the talk about then? This is opinionated commentary on some aspects of using revision control systems, based on things I've seen over the last years, making extensive use of revision control on personal, open source, and commercial software projects. Some of the stuff that I'm going to talk about may be more important or more impactful on larger projects with multi-person teams, but it's also important if you've just started a project that you think might grow into something bigger. Particularly if you have an open source project that you're trying to get contributors to, having a solid project history from the beginning makes it a lot easier to onboard new people and let them start contributing. Some of the stuff is maybe more relevant for repositories that contain code, but it's also applicable for documentation repos or configuration repos. Eventually, we're going to talk about how to make better use of the history in your repos. But first, before we can do that, we have to talk about how to make better history. For all the stuff I'm going to talk about today, there are a few prerequisites. For maximum value, you need to be very consistent in how you apply them. You want to make this stuff into a habit so that you don't think about it. Pretty much do it all the time, because then you don't have to think about it. Even better, if you are the right kind of twisted person, and it's a Perl conference, so I know a lot of you are, automate it. I periodically run a script that runs across all the repositories on my machine, which aren't all under my home directory, and it finds ones that are in a dirty state where there's stuff that hasn't been checked in or commits that haven't been pushed up to the remote, and I clean them up. I do that as part of my weekly review. This is a good habit to get into. So how do you make better history? This is a Git talk, so I'm obligated to talk about workflows. Potentially one of the more contentious aspects of starting a new project is deciding what workflow you're going to use with Git. And workflows with Git can range from very simple to just having a single branch in a local repository with no remote and just piling stuff up on top of the head. You can have that same basic setup, but with a remote that you push to so often. This is basically the simplest branching workflow that you can have, because These commits right here that are local, that haven't been pushed yet, that's a branch, effectively, of that repository. So if you're afraid of branching, but you've worked with this workflow, you've been branching, you just don't realize it. And this can go all the way up to extremely complicated and very sort of almost ceremonial workflows like Git Flow, where you have multiple branches in flight. You may have a team member that's specifically tasked with managing branches. Who uses Git Flow or something that similar? Okay, so maybe 25% of the room. With all of these workflows, regardless of what workflow you're using, there are some notable anti-patterns that I have observed in the wild. One is squashing branches. So this was one of the inspirations for this talk, and it may be a little too small to read, so I'll read it. This commit incorporates 6+ months of multi-topic work. This work was all squashed for clarity. Why? So don't do this, right? You're basically destroying a bunch of history that was built up over the course of doing that work. It doesn't make it easier to review. It actually makes it much, much harder. Similarly, fast-forward merges destroy the history that there even was a branch. It makes it, the branch basically effectively goes away, so don't do this. There's also, some people will rebase their branch onto head before merging. This is basically doing a lot of extra work to do a fast-forward merge. All of these things destroy history needlessly. And so another tweet from the same friend, I really don't get why people think if they destroy history, things become clearer or simpler for others or for themselves or anyone. A linear commit history is a lie. All of these things are designed to have the effect of linearizing the history in your Git repo and making it look more like there was just a single unbroken line. Any complex project, that's a lie. There were branches, there were false starts, there was stuff you put in, stuff you took out. So instead of doing those things, here are some good patterns. You should branch. Branch for everything. Like, this should be your default action on sitting down to start a new whatever. Make a branch. The specifics of this will vary depending on the size of the project, your policies at work, whatever, but make a branch. Have a release branch in your repository. You may call that release branch master. You may call it something else. Again, the specifics will vary, but make it so that merging to the release branch is a software release. Again, ideally, that happens automatically. You have continuous integration, continuous deployment, whatever. But when you merge into that release branch, that just became a new version of your software and you should release it. Make all your merges non-fast forward. So generate merge commits for everything. Bit of an aside, there is a file in your home directory if you're using Git that is called .gitconfig. This is where you can put configuration for Git that you want to be global. And there's actually a command, git space config, that you can use to manipulate this, or you can edit the file directly. So if you run these two commands, git config -- global merge.ff false, and git config -- global pull.ff only, that will cause in your git config file to appear these two stanzas. The git config file is unfortunately in INI format because, I don't know, Linus has no taste. But you'll get these two keys entered. What this will do is it will cause all local merges to be non-fast forward, except in the case where you do a pull. You don't want to generate a merge commit when you're just pulling down changes. That will do only fast forward merges and will actually refuse to apply the pull if it can't do a fast forward merge. The effect of this is it's going to preserve the maximum historical information in your repository about when a branch was created, how it was merged, who did all of those things, and when. You should also try to keep your repository clean. How many people have started work on a new project and looked at sort of the number of branches that are in the repo and been like, why are there 700 branches? And which ones are relevant? Because I know I've done that. So another thing you can do in your .git config is you can make aliases. So I have these aliases defined because I really cut my teeth on SVN and CVS, and these abbreviations are in my forearms. So this makes it so that I can type git br instead of branch, and so forth. And I spell commit CI because it really stands for check-in, not commit. So clean up remote branches. This is how you can delete a branch in Git now. They changed this, I think it was like 1.8 or 1.9 around then. Before that, you had to do a really sort of completely unintuitive syntax involving pushing to a remote with no... Anyway, this works now, so that's nice. What's even nicer is you can make an alias that looks like that, and then you don't have to remember the syntax. You can just say git nuke and the branch name, and it will go away. You can also clean up orphaned remote tracking branches. So if you have checked out a branch and it has is set up to track a remote branch and somebody else deletes that remote branch, you now have an orphan. This command will remove those. This will go through, and any branch that you have that has a remote tracking branch that doesn't exist anymore will be removed. I can't remember this either, so I just have an alias called Prune. And Git Prune cleans up all those orphan branches. Before you do this, you might want to find branches that haven't been merged yet to make sure you're not destroying some work. You can do that with this command. This will show you all of the branches that are not merged into master on your local machine, or you can add a -- remote, and then it will show you all of the remote branches that aren't merged into master. I make aliases for these too, because again, I can't remember things, so I have unmerged and unmerged remote. I see a couple people taking pictures of the screen. I'm going to put these slides online, and I'll tweet about it at the end. So if you're trying to capture specific things, it'll be available. So keep your repositories clean. One final note on branches, branch names. In my world, a branch equals a ticket. Every ticket gets a branch. So every ticket has an ID. The ticket ID should be in the branch name so that you know this branch goes with this ticket. You should also put something in the branch name for the human beings that you work with. Put the number at the end of the branch name, because the ticket number is not important to the humans. The ticket number is important for the machines to be able to automatically link everything up, which is very convenient. But if you put the number at the beginning, people have to skip over it to get to the important stuff, and that's annoying. So don't do it. So this is a good branch name. We know we're fixing something related to login. We know there's a ticket somewhere with an ID of 864. This is not as good. We're fixing something and we've got a ticket ID. This is bad. Because one, the number's at the beginning, and crap doesn't actually tell me as much as you think it does. And then this is no, right? Just don't. When you merge, include the branch name in the merge commit, because eventually that branch will get deleted or cleaned up, and if you don't put the branch name in the branch commit, you're not going to know what the branch was. You may not be able to backtrack to the ticket. Git has a default message for this. It works very nicely. It looks like this. So just, if nothing else, just leave that alone. Again, maximum historical information. Try to preserve all of the history that you can. So to review, don't squash. Don't fast forward. Don't rebase before merge. Don't destroy your history. It does not make things clearer. Do use branches. Do use a release branch. Do make merge commits and use non-fast forward. Do keep your repo clean. Okay, so let's get a little bit more granular. It's big grains of salt. Let's talk about structuring individual commits within those branches that you're all making. So in my world, a commit equals one change, one logical change to the software. And it's very important at each step, every commit, everything you check in, the software must work for whatever your definition of must work is. The test suite must pass. The reason for that is there's this command called Git Bisect. Who's used Git Bisect? Yeah, awesome. The last time I gave this talk, there were like 3 people, and there were more people in the room then, so I was sad. So I'm not going to explain what Git Bisect does other than to say it helps you step through your remote and find out, or your repo, and find out when a commit broke something. But if you have commits that you've checked in where the software doesn't work, Git Bisect becomes a lot more annoying to use, and sometimes it's just not possible. So keep the code working. If you're in doubt, a smaller commit is always better than a bigger commit. If you're not sure whether there are 2 things in there, there's probably 2 things in there. Split it up. Whitespace and formatting changes. Always, always, always. go into sync commits that don't include any code changes. And the message for that should say something like, white space changes, no code changes. Remember, too, when you're working, revision is a thing, right, that Git lets you do. What you eventually push does not have to equal the commits that you made while working. You can edit them. You can use commits like save points in a video game, right? I'm going into this room, there's a big boss in there, I'm gonna die, I'm gonna save my game before I do that. Some people will tell you to use Git stash for things like being interrupted on work. I hate Git stash. Does anybody like Git stash? Many people. All right, I hate Git stash. I inevitably come back and find that I have like 5 or 6 different things stashed. I have no idea what any of them are, and I just drop them. You can use a checkpoint commit instead. If you get interrupted and you have outstanding changes, just commit all of them. Every time I make a little bit of progress on something that I'm working on, I commit it. Every working micro step. Because I eventually built up this habit after getting to a point where I would have something sort of working but not all the way working. And in trying to get it all the way working, I would undo the stuff that was partially working. And then I couldn't even get back to partially working again. If you commit partially working, you can always get back to it. So if you look in a repo where I'm actively working, there will be a whole bunch of very small commits that all say WIP, work in progress. A single change for me that eventually gets pushed as a single commit, maybe 10 to 15 actual of these micro commits. So there's a flag to git add called -- patch. Who's used git add patch? Not very many people. So what this does is this steps through all of the changes that you have in your local copy and allows you to stage individual bits. It's awesome. You can abbreviate it git add -p. There's also git commit -- amend. Who's used amend? All right, many people, good. So this allows you to make a change to the most recent commit that you did. And as long as you haven't pushed it yet, it's fine. It's nice to have editor support for these things so that you don't have to flip over to the command line and you can just do it in your editor. Emacs has a package called Maget that lets you do this. Vim has Fugitive. And Adam recently added a GitHub package that also lets you do this. This is what this looks like in Maget. So it's showing me here, this is actually from the slides for this talk. And it's showing me I have a couple of sets of changes. I'm staging this set, which is why it's highlighted. I'm not staging this set. And so it's really nice to be able to pop this open in your editor and go through all of your pending diffs and say, yes, this, not this. And it lets you split up work into individual commits a lot easier. Don't push your first draft. Think of writing your code like writing a story, right? You're trying to tell a story with your branch. You wouldn't turn in the first draft of an essay at school, or if you did, you wouldn't expect to get a very good grade. So there is a command called rebase -I, interactive rebase. Who's used this? Good, a good chunk of the room. This is awesome. Rebase allows you to take a series of commits that you have on your machine, reorder them, pull them apart, squash them together, and it's great for, once you've got the thing working, structuring the branch so that it's going to be easier for somebody else to code review. This is a visual demonstration of what Git Rebase lets you do. You can just take a commit completely out and make it go away, too. So I ranted a little bit earlier about keeping your repository clean. I also want to note that it sometimes may be useful to preserve particular branches, dead ends, as a warning to others. So the type on this is actually also really small, so I'm going to read it too. It says, "Dear maintainer, when I wrote this code, only I and God knew what it was. Now only God knows. So if you're done trying to optimize this routine and failed, please increment the following counter as a warning to the next guy. Total hours wasted here equals 67. I actually have a commit like this in one of my pieces of software because I realized that there was something that looked like it would be better if it was done a particular way, and then 3 levels later, you realize it's not going to work. And I did that 3 times. So if you have something like this, you can leave this around as a branch just forever. Marked don't do this. All right, so commit messages. Again, ticket numbers should be in the subject. They should be at the end of the subject because, again, that's for the machines, not the people. You can customize the template for the commit message in your repository. This is another thing you can do with Git Config. So this command, git config -- local commit.template, and then the path to a file. And then that will be the template that shows up when you make a new commit. If you do get to this point and you're working with other people, you're going to want to script the setup for your repository because they're going to need to run this config on their machine too in order to see that template. But if you have a highly evolved procedure or policy at your company or your work or your project where specific things have to go in a commit, put that in the template because it's nicer. So good commit message examples. This is a good commit message. Make the login form use post instead of git. Number 864. We're fixing that login problem. This is good. This is less good. So I have a personal preference for putting the ticket number in square brackets like that because I think it makes it stand out a little bit more. I'm not like super anal about that, but this is not good. The ticket number's in front and fix tells me absolutely nothing. And then we have my absolute favorite commit message of all time. Who's worked on a repo like this? I know you've worked on the same repo. I'm not going to say who this was, damn it, Stephen. This is why Daddy drinks. So, like, to review, one commit equals one logical change. You need to decide what constitutes a logical change. But one change per commit. Commit messages matter. When in doubt, make it smaller. Make the commit smaller, not the commit message. Just to be clear. Segregate your formatting changes to separate commits. Don't mix whitespace changes and code changes. It makes diffs annoying to read, and it's a bad thing to do. Use checkpoint commits as save points. Don't push first drafts. Revise your commits and your branches to tell a story, or to at least make yourself look smart. There is absolutely no need to have a commit that does a bunch of stuff followed by a 2-line diff with a commit message of typo or oops. You can squash that crap on your machine before you push it, and then I don't have the impression that you're not that bright. All right, so now that we've made better history, how are we going to use it better? The first thing and the most important thing that you can do to make better use of your Git history is JFRI. Just friggin' read it. One of the other inspirations for this talk was I was talking at one point with Jesse Lewers, some of you know, used to be a Perl programmer, and he's departed us for less pearly pastures. And he was saying when he starts working on a new project or goes to contribute to an open source project for the first time, he doesn't look at the code. He reads the Git log. He reads the commit history. Because not only do you see the code in there, but you see what parts of the code are changing over time, what parts of the code are changing more actively. You can even get a feeling for the personalities of the people who work on the project by how they structure the commits and what the commit messages are. And I was really struck by that because that wasn't, at that point, something that I had ever done. But now I do. And it's amazing how many projects that sort of look attractive, and then you look at the commit history and you're like, nope, not getting into that. So things that make it easier to read your history, going back to Git Config again. Git has pretty extensive color support, which is really nice. If you put this in your config, this sort of turns on the maximal color usage for all of these commands: branch, diff, grep, interactive, show branch, status, and UI. A million lovely colors. You can also get a little bit more detailed, and you need to dig through the documentation and sometimes the source code to find the specific keys you need to use, but you can set up your own custom colors for all of these things. So git diff, things that make using git diff a little bit easier. There is a flag git diff-w. This will ignore whitespace changes and will only show you actual real changes. This is what it looks like with color support turned on. For anybody who is red-green colorblind, I apologize. Git uses red and green for this stuff. So if you're looking at that and saying, I don't see any difference, one of them's red and one of them's green. And this is a case where you should customize the colors. Thanks. There's also a flag to diff called word diff that will show you just sort of isolate the changes within the line to just the parts that were changed. And word diff normally uses, it's a little small, it normally uses punctuation characters to highlight the changes within the line, but you can also pass it a line, word diff dash dash color, and then it will just show red and green right within the line. Just super convenient. If you're staring at a line and going, what changed here? This makes it really easy to isolate those changes. All right, so there's a command called git blame, which can also be useful for looking through your history. Who's used git blame? All right, most of the room again, cool. Why'd you guys come to this talk? You already know all this stuff. Here are a couple of flags that are useful to use with git blame. -w, again, ignores white space changes. -m will track changes that are made within a single file. So when you move a block of lines within a file, the default algorithm that git blame uses can get confused by that and will end up showing you things that are not quite right. -m makes it a little slower, but correct. I also, again, because I cut my teeth on CVS and SVN, they had a command that did exactly the same thing as blame, but it was called praise. And I actually think most of the time when I reach for git blame, I am looking to blame somebody. I'm like, who did this? I will find them and punish them. How many people have run git blame in anger and found out that it was themselves? Again, most of the room. So occasionally, I like to hold on to the hope that I'm looking at this information because there's something really cool, and I want to find out who did that and tell them they did a good job. So I set up an alias for blame so that I can say git praise. It's just a nicer thing to do. Again, integrating this stuff inside your editor is convenient and very possible. I have a command that I wrote called git blame for line that shows me the blame for the line my cursor is on. I'm sure there's an equivalent for Vim. A few examples of blame and log commands. So they both take a -L option that will allow you to restrict their activity to a series of lines. They also take a file option so that you can run it on just a particular file. Because this is Git, they don't actually have the same syntax. It's almost the same, but with git log, you have to put a colon between the line numbers in the file, and with git blame, you have to put a space. So close. So this is how you would get the blame for the first line of a file called index.html. You can do ranges. So this gives you the blame for lines 10 through 50. You can also do offsets. So this gives you 10 lines starting at line 20. And git log takes all of those same options. You just have to put that colon in there. There is also a flag to git log called -s, which is referred to in the documentation as the pickaxe option. I didn't have a picture of a pickaxe. I just have a hatchet, but it's close enough. Who's used this? I just learned about this recently. Maybe 20% of the room. What this does is it takes a string argument and then shows you the most recent commit that changed that string in some way wherever it occurs in the code base. So if you're looking at for like who changed this function or where it was called, this is a great option. There's also a flag to gitlog --follow. What this does is it makes gitlog follow files across renames. Normally, if you rename a file in Git, you just broke the chain, basically. Git will not backtrack across that rename. It's computationally expensive. --follow, this will only work on one file at a time, unfortunately. But if a file has been renamed, this is a good way to track back across the rename and find out what was going on before that. I have a command I use a whole lot that I found somewhere on the internet, and I don't remember where anymore. I abbreviate it to gitlg. That expands to that. Don't try to read that. I'll show it to you in a minute. What that does is it produces output that looks like this. So you get the branch history down the left-hand side so you can see where a branch was made and where it was merged and a whole bunch of other useful information. So now I'm going to step through the various options. --graph is what gives you the graph It's right there in the name. --abbrev commit truncates the SHAs to 6 to 8 characters, depending on the size of the repository. Otherwise, if you don't do this, you get the full long complete SHA, which you don't generally need. I like to add --date equals relative, so that instead of an absolute timestamp, I get things like 2 days ago, 6 weeks ago, 8 months ago. I just prefer that. And this is the thing that does the formatting. Completely understandable. I'm not even going to explain. Anyway, this prints the SHA in red, the branch name, if there is one, in yellow, the commit subject, just plain, the date in green, and then the author in blue. And again, this is all very customizable. If you've unfortunately ever had to deal with color escape sequences in a shell, this should look reasonably familiar. And again, that looks like that. I run this approximately 7 million times a day when I'm coding. Particularly, actually, one thing that it's super useful for is if you have a complicated merge flow and you're trying to figure out what's going on, being able to visualize the branches like this is awesome. All right, so takeaways. History is important in your project, in your repository. It's probably worth more of your time, both creating it and using it. You shouldn't just stop thinking about this stuff or worrying about the structure of it when the software works. Software development is actually really hard. It is not an easy thing to do to build good software. I've been doing this long enough that I feel comfortable saying that. If it is easy for you, come tell me what I'm doing wrong. So be kind to other people as we all engage in this collective difficult effort. If you don't like other people, be kind to your future self. Thanks for coming. Thanks to the organizers for accepting the talk. Thanks to my employer for paying to send me here to talk to all of you. And we have plenty of time. I'm happy to take questions.
So if you're in a position where you're an open source project, you've got a Perl module, and you're actually popular enough to be taking multiple pull requests from multiple sources, given your suggestion about not squash merging and not rebasing, what do you do? I mean, you've got to put one in, rebase the other, or just merge them in and it's a conflict for a back.
So the question is, what do you do if you have multiple contributions coming from multiple sources at the same time, and how do you handle merging that? In my experience, most of the time, even in that situation, it's very rare for two people to be working in the same region of the same file at the same time. So git merge will just merge everything cleanly. If you do get a merge conflict, you do have to sit down and look at it. One of the times when I will grit my teeth and with great regret rebase a branch is because I'm staring at, I can rebase a branch and it'll just merge, or I can spend 4 hours trying to figure out how to resolve this merge conflict. And in that case, I'll rebase, sure. Because principles are good, but pragmatism wins. But in my experience, most of the time, it doesn't happen. People generally aren't making changes to the same section of the same file at the same time on different branches. And that's the only real case where you're going to get a conflict, is if two people are trying to change the same thing at the same time. And actually, if that is happening, it's probably a sign that you should tell those two people to talk to each other.
The only place it breaks down is if you've got semantic problems. He's working on this section, she's working on that section, and she did something here to break the API that he hasn't seen yet. Now,
and again, those
merge them, boom, it's going to blow up. That's why you have testing.
You are in search of a technical solution to a social problem.
Okay. I'm just.
And sure, it's just, 99% of the time, the technology is not the problem. Making the people talk to each other is the problem. You lose the timestamp. So why don't I recommend fast forward merges? You lose the timestamps. You lose the metadata about when the branch was started. And you lose the metadata without a merge commit. In a more complicated workflow, the person doing the merge is probably not the person who wrote the code. It's probably the person who did the code review. And you lose the information about who did the merge because there's no merge commit. And if you do have, I will frequently, if I do get a merge conflict, I'll put the information about the resolution in the merge commit. There's a commit message on the merge commit for a reason. You can put metadata about the circumstances of the merge in that commit. You don't have to just use the default message. You can add stuff to it.
Yeah, I'm not necessarily a fan of Stash, but I find it a necessary evil in a situation where, you start working on a branch and you're taking all your Legos and throwing them on the floor. Someone comes in and says, hey, we need to do something in this other branch. And they're using in that situation to commit Legos all over the floor.
So the question is about using checkpoint commits versus git stash. If you're in the middle of working and need to suddenly switch and work on a different branch, yeah, I would, in that case, like if I need to switch to a different branch because production is on fire, I will do git add dot, git commit dash m WIP, return, and move on. And the nice thing about that is, you've got your Legos spread out all over the floor. You can come back to that exact arrangement of Legos by just going back to that checkpoint commit, and then when you finish putting together the spaceship out of the Legos, you can git commit dash dash amend and change that message from WIP to something informative. You don't push it. It's only local on your machine. And it's exactly the same as git stash, but you can actually put a message on git stash that tells you what it is, but one, I never do. Maybe you're more disciplined than me. And two, I come back and there are 3 or 4 git stashes, and I try to pop one, and it doesn't apply cleanly, and then I'm like, well, god damn it. And then I just throw it all away and start over. So, Dave?
Are you familiar with git re?
I was actually, so am I familiar with git re? And I was actually tempted to mention it when answering his question. So for those who aren't familiar, git re is a command that will, when you do have a merge conflict, it will record the resolution. And then if you ever run into that same merge conflict again, it will reapply the resolution that you previously picked. Yeah.
I don't have a question. I just wanted to say that, or suggest that so I use it all the time with reset. I always debug crap in there and add it. And took the time to git add patch, all these different lines and give it one extra line. So I wanted to say that you can git reset to pull that line out.
Awesome, thank you. So you can use git reset head patch to pull out unstaged stuff. Yeah. So yeah, the last time I gave this talk, actually, there was a suggestion about this too, and it's on my list to add, and I didn't get to add it to the talk. There's a command called tig, which is, I think, incurses based, kind of git helper. If you're not... And the main reason I don't use that is because I use Emacs, and Git does all that stuff too, just inside the editor. Walt. Right, so the question, I'm going to summarize a little bit. Justify the hypocrisy between saying commit all the time but use rebase to make your stuff look pretty. Is that, okay. So one, yes. Two, the commit all the time is just about preserving local microstate. I don't push those. But I git commit like I am working on a term paper that's due that night on a computer that has a flaky power supply, right? Like people used to obsessively hit Command S or Control S, I git commit. And it largely is because I've so many times, you're trying to get a complicated thing to work and you get part of it to work, and then in trying to get the rest of it to work, you undo the first part because you think that maybe you didn't do it the right way. And now you're all the way back at 0 and you can't even get back to where you partially were. And after about the 5th time I was like, damn, if I just committed that, I could just go back. I started doing it. But I don't push that. The stuff that I push is, for lack of a better word, groomed, right? So you build up the mess, and then instead of pushing the mess and inflicting it on other people, then I stop and go back and look. And my working tree will be full of things with commits, like with typo. I will actually do typo commits locally, but then I go back and find the change that introduced the typo and just make it so that the typo never existed. And I'll have commits like squash into thing, because I did one thing and then I did a different thing, and then I realized I needed to change something in the first thing. But I don't want to deal, and so you build up this mess of junk, and then you edit it using Rebase to smooth it out and tell a better story. I have one guy I work with, Mike Eldridge, who I take absolute pleasure in doing code review for him because he structures his commits so nicely, where it's just this beautiful logical progression of stuff getting built up, and it's so easy to code review because he makes it easy. So your coworkers will appreciate that. Git blame minus whitespace commits. I think -w works on Git. Yeah, actually it does. Just -w will ignore whitespace. That's on almost all Git commands. Actually, you can do git log -w and it won't show you the whitespace change. If you do git log -w-p to see the patch diffs in the log, -w will make it not do whitespace. Steve? No. So am I familiar with git commit -- what was it, fixup and rebase auto squash? No. Okay, so basically this lets you apparently automate the thing that I've been doing manually like a jerk for... Awesome. I love giving talks because I learn things. Yes, sir.
So the idea you have about the hours wasted here, the question is, if I see a piece of code in master, nothing in my workflow is going to check other branches of that code to find that. So what are you doing that I'm not?
How do you store mistakes in branches, but also let people know that, like, how do you surface those branches and let people know that they exist? I've never actually done that in practice, but if I did, I would put a commit in the real code saying, before you change this, go look at this branch. James?
Yeah, I'd just like to mention the two commands, git format patch and git am. In the work on the Perl 5 core distribution, we use those a lot to create patches and to apply patches. That's in large part because the core distribution precedes most of these version control systems, and we originally received patches strictly as attachments to emails. And so we have to be able to accommodate a large variety of ways in which people send us diffs and getting it into the distribution. And a lot of our work proceeds that rather than the workflow model in which you fork a branch and then later someone merges it into the branch. And frankly, I happen to like it a lot because I don't, myself, don't like to look through a code, a log with many commits that are strictly merge commits, particularly merge commits that don't have anything, any other information attached to them. They may not be applicable in other contexts, but I do think that people should be aware of Git format patch to create a patch, Git AM to apply, and also there's another one, Git apply, and there's Git patch, and I don't remember the context of what they occur, but they're in the documentation.
For what it's worth, there is a flag to Git log that will ignore merge commits. Anybody else have questions? Yes.
So for corporate authentication, material
I actually had one Mercurial. Who's still using Mercurial? Two people. Okay. There was one person in the last talk who had a Mercurial question, and I'm sorry, I forget that exists. I have that luxury, so.
we're trying to move again.
Yeah, I'm sorry. Chris? No. This is not the tour of distributed revision control mistakes talk. That's a different talk. So here. There is a Git Mercurial. You can use Git as a front end with a Mercurial back end in the same way that Git SVN does. I have no idea what that ends up practically looking like. I was not the hugest fan of Git SVN. That it's not quite a square peg in the round hole, but it's very oval. And just greased up, and it doesn't work very, very well. Not a fan. Anybody else? I'll be around all day. Come find me. I think I'm out of time anyway, so.